Static charge, also known as static electricity, is the accumulation of an electrical charge on the surface of an object due to a transfer of electrons between materials. This charge remains in a fixed position and does not flow like current electricity. It's often created by friction or contact between different materials, where one material gains electrons and becomes negatively charged, while the other loses electrons and becomes positively charged. Static charge arises from an imbalance in the number of positive and negative charges within a material. When two materials are rubbed together or come into contact, electrons can be transferred from one to the other, creating the charge imbalance. To use static electricity to charge a battery, you would need a device to convert its high voltage and low current into a lower voltage, but moderate current. While it's not a practical way to charge a battery, static electricity can theoretically be used to charge a battery. However, the high voltage and low current associated with static electricity are not sufficient to provide the current needed for practical battery charging applications. To make static electricity useful for charging, it would need to be converted into a lower voltage, moderate current electrical flow. In essence, static electricity is a buildup of charge, not a continuous flow of current, which is what's needed to charge a battery. While the concept of using static electricity for battery charging is theoretically possible, it's not a practical or efficient method. Batteries charge by chemical reactions that transfer electrons, negative charge, from one terminal to another, creating a voltage and current flow. Momentum is a fundamental concept in physics that quantifies the motion possessed by an object. It is defined as the product of an object's mass and velocity. In other words, momentum is determined by multiplying the mass of an object by its velocity. The formula to calculate momentum is momentum equals mass times velocity. Momentum is a vector, meaning it has both magnitude, amount, and direction. Momentum is related to force. A larger momentum means more force is needed to change an object's motion, like stopping it or changing its direction. The total momentum of a closed system, no external forces acting on it, remains constant. This is the principle of conservation of momentum. A heavy truck has more momentum than a lighter car if they are both traveling at the same speed, making it harder to stop the truck. A truck full of goods has a large mass, and so it must slow down before a stoplight because it has the large momentum with the same velocity, and so it is very difficult to stop. During a game of baseball, a pitcher's fast throw causes the ball to have momentum. The speed of the throw directly affects the amount of momentum the ball has. Likewise, when a batter uses a bat to hit the ball, they transfer momentum to it, which influences how the ball will move and how far it will go. The efficient design and operation of vehicles relies heavily on momentum. For example, when a car speeds up, it acquires momentum, and when it slows down, the momentum is transferred to the brakes, resulting in deceleration. Knowing about momentum enables engineers to create effective braking systems and enhance the safety of vehicles. In the field of construction, cranes utilize the force of momentum to hoist hefty items. The operators of these cranes create momentum by swinging the crane arm, thereby enabling them to lift heavier loads with minimal exertion. Similarly, engineers consider the concept of momentum while creating roller coasters. The law of conservation of momentum states that in an isolated system, the total momentum remains constant. It is neither created nor destroyed, but only transferred between objects. This means that in the absence of external forces, the total momentum before an event, like a collision, is equal to the total momentum after the event.